Hello, and welcome to the Spring 2026 Improving Restorations webinar series, collaboration between the University of Minnesota Extension and the Legacy Fund Restoration Evaluation Program. The webinar series that has Minnesota's restoration practitioners talking. Today, you'll be learning about stream improvement planning and collaborations. I'm Wade Johnson with the Minnesota DNR, also on behalf of the Legacy Fund Restoration Evaluation Program. With the Minnesota Board of Water and Soil Resources. Our program collaborates with experts. Whoa, sorry, I skipped a slide there. Our program collaborates with experts to evaluate restorations, identify what's working and ongoing challenges, and working through venues such as this webinar series to share information to improve future restorations. Our collaborating partners for this webinar series are the University of Minnesota Extension. Chelsea Blanky with the U of M Extension is with us today and will field questions for a shared Q&A after both of the presentations. Extension offers an online ecological restoration training certificate program. This is a great resource for continued learning in the restoration field for everyone from early career practitioners to seasoned professionals. During our webinar today, as questions and comments arise during the presentations, please use the Q&A icon at the bottom of your screen. There's also a chat feature you can use if you're having technical issues, but please use the dedicated Q&A field for questions, and we'll have time after both presentations for a Q&A discussion with the speakers. At the end of the webinar today, you will see a pop-up when you close Zoom, prompting you to complete a short survey. Please take a moment to complete this survey as it gives us valuable feedback about your interests and potential topics for future webinars. This webinar series will be recorded and available on Extension's website. Without further ado, introducing today's speakers. Jennifer Biederman is Habitat Coordinator with the Minnesota Trout Unlimited, coordinating restoration projects on cold water ecosystems across the state, including in-stream habitat improvement, riparian forestry, and fish passage. She has done research on cold water ecosystems in the Driftless area, including on seasonal feeding and growth dynamics of brown trout. Our second speaker today is Matt Kempinger. Matt is an engineering technician for the Southeast Minnesota SWCD Technical Support Joint Powers Board. He provides technical assistance to soil and water conservation districts across 11 counties in southeast Minnesota, designs and implements a broad range of conservation practices from agricultural best management practices to stream restorations. Through his current position and previous roles, he has spent about 12 years studying and working on aquatic ecosystems, erosion control, and watershed level conservation. And with that, I will hand it off to Jennifer Biederman for the first presentation. Jennifer, take it away.
I'm gonna share my screen. All right, I think you should all see the correct screen there. So I'm going to kind of jump right in. So what I wanted to talk about today was kind of the lessons that Minnesota Trout Unlimited has learned through the years about how partners and collaborations can really improve the outcomes of our projects and also the quality of the projects through the design and construction and post-project monitoring. So I work for Minnesota Trout Unlimited. So we were established in 1959, but I think a lot of the real meaningful habitat work or significant habitat work has really been happening since about 2009, 2010, and much of it is using the outdoor heritage funds that have been available since that time. And restoration really is kind of at the core of our mission as an organization. So, trout streams, of course, they're dynamic systems. Watersheds are shaped by the water that flows through them, the sediment, the connection to the floodplain, land use. And it's really hard to find a stream in Minnesota that has not been touched by something. So if you think about the majority of our streams have been, either historically straightened, some of them are ditched, they've been grazed or overgrazed, fragmented, logged, burned. There's just a lot of stressors that have been put on our streams. This is a picture here of South Creek, which is a cold tributary to the Vermilion River in Farmington, in Dakota County. And you can see at the time of 1941, it hadn't been ditched yet. Unfortunately, a few decades later, it was ditched, and this is a current project that we have in design that we're working on. And so you can see today, the project has been largely straightened. And when you're on the ground looking at this project, it's, the degradation is pretty visible to the eye, the actively eroding banks. It's wide, it has trouble passing sediment. And so a big part of our work is trying to fix these types of problems in our streams. So we think about, the mission of Trout Unlimited, of course, is one of our focuses is angling and fish habitat. But we understand that fish are the product of a healthy watershed. And so restoring a stream like South Creek from a ditch back to a restored state will do a lot more than just improve fish habitat, which we like. It'll also address water quality. We look at benefits like flood resistance, so reconnecting access to that floodplain, recreation and access. So you might have noticed in the previous, more recent aerial map of the project area, there's now housing developments in this watershed. And so this is, it also occurs on Dakota County parkland. So we have to think about, how can we improve the ecology of this system, but how can we also make it maybe a better place for people to engage with nature and perhaps angling. And then of course, biodiversity and ecosystem function. So as I mentioned, this is the coldest tributary to the Vermilion. And so it's a really critical part of the trout fishery, which is a rare thing in an urban part of the Twin Cities metro area. So for us, it was a high priority. So when we prioritize streams that we're going to work on, sometimes people have the impression that what we're doing, the streams that we're working on is random, but it's not. It's really strategic in terms of where we're working and why. We look at things like, biological values. So what are the existing trout populations? Is there natural reproduction or is there potential for natural reproduction? What's the carrying capacity of the stream? Can we improve that or increase that? What are the physical impairments of the stream? Is there bank erosion? Is it incised? Is there embedded substrates? Are there barriers to movement or passage of fish? Looking at the watershed, we look at things like cold water inputs, like are there springs? Is there a lot of groundwater? What are the land use trends in the area? What are the sediment nutrient sources? And then also public benefit. Is there angler access? Is it accessible? Could we improve accessibility? Feasibility. Is there landowner support? At times we'll run into a place where, we would like to do a project, but perhaps there are some kind of prickly landowners that might not make the project an enjoyable experience. So you might lower that on the priority scale. And then, other things with feasibility is like, is it eligible for funding? Are there any potential roadblocks with permitting that we can see and constructibility? So we use a lot of tools in order to prioritize projects. So this is an example. So we were intended to do a lot of fish passage work or culvert replacement work up in northeastern Minnesota. And in order to do that, we didn't want to just go around kind of plucking random culverts that looked like they were barriers at random. So instead, we worked with the DNR offices up there who were doing some temperature saturation studies. So this is one in the Manitou where they put out temperature loggers all over the watershed in order to figure out where the areas that were most suitable for brook trout based on fish temperature, based on water temperature, which is a critical component of their habitat in Northeast. And so we used that data from them to prioritize which culverts were maybe the most critical in getting fish to have access to the proper thermal habitat at different times of the year. So that was really important for us. As we expand and try to do more of this work in other watersheds in the Northeast, there's times when, DNR staff and funding is limited. And so they can't just go out and do temperature saturation studies in every single watershed as soon as we want to have it done. And so we have one really important thing for MNTU has been to have regular coordination meetings with the area fisheries offices in order to identify what their gaps are in data Are there ways that we can help? What are their priorities? And through this, we were able to have some TU volunteers go out and actually deploy some temperature loggers in a watershed to kind of help out with gathering some of that data. So that's been really important. Another thing is trying to use feasibility studies or planning in order to prioritize where to work in a watershed. And so, and we've done quite a bit of work in Keene Creek, but that process was premeditated with a partnership restoration master plan that was done with South St. Louis Soil and Water. And so that was really important and actually kind of laying out like in different parts of the watershed, what makes the most sense to start with in terms of ecological uplift? Where do we work first? Where do we go to next? And using data to actually drive those answers instead of just randomly saying, well, this looks good. Why don't we work here? And so that funding the prioritization work. So funding something like a master plan or feasibility study is difficult to find that funding. So we try to leverage that with partners whenever is possible. And so since then in the Keene Creek watershed, in the last 5 years after that study, we've done 3 pretty cool projects, again, that were guided by that plan. So Minnesota Trout Unlimited, we try not to function as an island or as a silo. We're always working with partners from the management authorities to the landowners to the local neighbors. So the South Creek project, which I talked about at the beginning, it's on Dakota County parkland. It's within the Vermilion River Watershed Joint Powers Organization. There's a new housing residential community that just popped up nearby. There's just a lot of players, that have interest in this restoration. And so we, when we're doing design meetings, like you can see here, we did our first field walk last month, followed by a kind of a office session where we were looking at data and whatnot. It's really important to have everyone in the room. Design, engineering, and oversight. So we do a competitive bid process with an RFP for our design and oversight. And the things that we've learned over the years that have been really important is when we are, when we seek comprehensive design services from an engineering firm, is that we want to use a geomorphic approach, of course, and we want to make sure that the data is available to us, and also that we can provide that data to the DNR. We have found another key element that can be really important are design reports. And so this is a sort of the instruction manual that accompanies the plan set that's handed to the contractor, but basically gives some accountability for the decision making in the design process. So what were the boundary conditions? What are the geomorphic variables? What is the reference reach data? Why, what type of vegetation reestablishment is being done and why. So it's a really good accountability tool and a planning document. We also require ecological management plans for after the project. So what do we need to do when the project is over? We do a lot of coordination with partners and agencies for the design, permitting, installation, and follow-up. We require 100% construction oversight, which I'll talk about in a little bit. And then recently, in the last few years, we've started requiring 3 years of inspections by the engineering firm 3 times a year for 3 years in order to see how the design is responding to high flows and all that good stuff. So we include all partners throughout the design process. So an area hydrologist, for example, is invited to our very first design walk. The last thing that we want is that hydrologist to learn about our project when they get the public waters permit application. We work a lot. I would like to call out and kind of shout out the stream specialist, the DNR stream specialist. So that would be Dusty Hoffman in southern Minnesota, and then Brady up in northern Minnesota. They've been a really great partner to have. They connect us with different facets of the DNR, the clean water specialist, the natural heritage staff, all of the stuff that kind of comes up throughout the design and permitting process. They've been really good at helping us troubleshoot issues and problems, and also providing some oversight. We do lots of design walks, again, inviting all partners to the table so that everyone's kind of in the room from the get-go. So when stakeholders, a lot of times when we're doing a project, particularly in a more urban area, so I'll use an example of, we have a project going on in Lanesboro on South Branch of the Root River. This project was conceived of with the local fly shop there, but it's been a few years since we've been able to get funding, and now we're ready to do the project. And, we kind of heard some rumors and maybe some some discontent with the goals, what were thought to be the goals and objectives of our project. So we from the get-go early on, we had several design walks where we actually invited the public and local fly shops and got the local fly shops and guides, neighbors to understand what our goals and objectives were. We had several public meetings and we listened to their ideas and their concerns, and we incorporated that feedback into the various iterations of the design until we were able to get approval from the Lanesboro City Council, and it was a great process. I think in the end, everyone is so far fairly happy in terms of what the goals and objectives of the design is, as well as things like timing of the project, like when does it make sense to actually do construction. There were a lot of details that had to be worked out and a lot of voices that had to be heard. So the design process, of course, I think everyone in this, I imagine everyone in this webinar is pretty on board with taking a geomorphic approach with the natural channel design. Stream science, I guess what I'd like to say about this is stream restoration is a relatively young science and we're continuously learning. And I think, webinars like this are a great opportunity to kind of move the needle a little bit on what we know. Over the years, even looking at Minnesota Trout Unlimited's projects, we've, I think, gotten a lot better at trying to find creative ways to improve the habitat. So the focus with the outdoor heritage funds for us is habitat. So we really do have to focus on stream habitat when we're doing our projects. And so we incorporate as much of that into the design as possible. And we really use input from the DNR fisheries during this. So when we're doing design walks, like, does it make sense, to stick a pool log here, or, what kind of pattern do we want to see with different habitat features? And so DNR fisheries input has been very important with that. And also from our anglers, kind of what kind of features they associate with having good habitat. So that's been important. Even in our culvert, even in our culvert projects, we try to go the extra mile in terms of like really finding ways to put habitat into the projects. So, we tend to think about them as being, fish passage projects as being, making sure fish can get to the proper temperatures they need, but there's also opportunities to add good habitat. So this Keene Creek culvert that we replaced up in the park in Hermantown, one concern that we heard from the public beforehand was that, there was a really nice pool on the downstream end of the culvert, and there was concern, it was a great fishing hole, and there was concern that we were gonna, that would be lost in the project. So in the design, we tried really hard to make that pool even deeper and better. We took an opportunity to add tow wood into the pool. In the culvert, we put a bankful bench and good substrate. So we tried really hard to focus on the good habitat. Sometimes our chapter members, we have a habitat committee of chapter members across the state, and Peter up in Duluth, many of you probably recognize him. He was keeping an eye on construction and development of the project. And he actually kind of noticed in the pool, he's like, well, there's all these boulders around. Like, do you think we could put some boulders in the pool to provide some habitat? And so we did that. And so we call it Peter's Boulders now in that pool, providing some good fish habitat. The lower part this is a design detail showing a culvert replacement up near Finland and Matson. And so in that one, we used an opportunity to put some nice step pools in the culvert to create some good fish habitat. So again, we're always trying to kind of move the needle in what we're doing. And that isn't just limited to the fish habitat. We also are looking at ways to provide non-game habitat. So actually installing dead trees for snag trees, wetland scrapes, turtle basking logs. And then when we grade back those banks, those eroding banks, it's great for reconnecting floodplain, but we are actually eliminating some habitat for like nest, like swallows and kingfishers that nest in them. So we found an opportunity to take some of that excess soil, stockpile it outside the immediate floodplain, and scrape it and create some good nesting surfaces for the habitat that we got rid of. This is an example of a design from 2009. So this is an older design. It was like 4 pages long. They've come a long way in terms of adding a little bit more of the geomorphic principles and data. So these are more recent designs where we have, where we have existing conditions, we have longitudinal profiles, cross sections, and then design details that point out exactly what we want the contractor to do with some better instructions. So I won't go through these in detail. Many of you have probably seen them, but I think the designs have come a long way. We design to bankful now. Bankful is probably our most important metric that we're looking at when we're creating the design. So making sure that the designs are done with bankful in mind is very important, and having very detailed design details for the contractors, so they're not guessing at things. For the design process, permitting is extremely important. So start early. NHIS, the Natural Heritage Review, can derail a project pretty quickly. So we start that process really quickly. There's, even the worst case scenarios. In one case, we found an undocumented rare plant after the contractors have mobilized. That can have a positive outcome in the end, even though it kind of delayed the project a little bit. We have the University of Minnesota Arboretum staff is now studying that plant and how it propagates, and then how effective the transplanting is working. So they're learning something about this rare plant. In the construction process, having a pre-bid meeting with all the partners is important. Having pre-construction meetings with a checklist of all the things you need to think about on the site. Oversight is super important. So we found that even sometimes oversight of the oversight is important. And that's not a dig on the design engineers. It's that there's a lot going on and more eyes can help. So myself and our DNR stream specialists are great with providing some of the construction oversight to help out the engineers. I'm doing a punch list before the contractors demobilize. Again, with the checklist is great. And then that 3-year construction maintenance and warranty is important. So for that 3-year maintenance, so we consider our projects are not done when the equipment leaves. Sometimes high flows can teach us about the design, and sometimes that might mean maybe we got something a little wrong and we need to go back in and fix it. And so we have inspection reports like this one from Cedar Valley Creek where we can go in and fix things. We also find that our projects create more opportunities for monitoring and engagement. So we have our chapter members will, in some cases, like at the Cedar Valley Creek project, the landowner was really on the fence about the project but he wanted trees. And so we're like, we'll plant you trees. And so we planted a lot of trees for him and it made him very happy. Monitoring is difficult. It's hard to fund, but soil loss erosion estimates are an easy way to be able to do that. So we usually do estimates on our projects of the soil erosion beforehand and then afterwards. And that's a good quantification that you can have to show that, there was an uplift in what we did. So this is pre and post of Cedar Valley Creek. Pre and post geomorphological surveys can show you how you move the needle on, creating riffle habitat or creating pools. And so we require both of these surveys, but they can also be used to have a data point on, that something worked. We try to work with local researchers and local universities. So Winona State did follow-up electrofishing at Cedar Valley Creek, one of our projects, and they found that, the demographics and the habitat use actually improved with the project. So another opportunity to have some data that it worked. Their geoscience department is also doing some ongoing geomorphic monitoring of the project, which we will learn from to see how does the profile of the stream, are the cross sections changing after we do this project? So that's been a great opportunity. A local group does some citizen science monitoring. So since we did the project in 2003, in the last 3 years, they've sampled twice a year and they're showing continuous improvements. They just sampled last week and they're like, this is the best measurements we've had in water quality and macroinvertebrate diversity. So that's been important. Long-term follow-up, we work with our chapters and continuously seek outdoor heritage funding for additional enhancements to keep the projects looking good. Our lessons learned, stream science is advancing really quickly. So permitting requirements, early and continuous coordination with partners goes a long way. Regular meetings with DNR fisheries once or twice a year with the area offices has been great for communication and prioritization and implementation. Public engagement is important. There's constraints to design and there's some misconceptions, which we don't have to talk about now, but there's some misconceptions, I think, with natural channel design, trees and beavers that we can all continuously talk about and learn better, I guess. And then my last slide is how can we find more opportunities to learn? We all do better when we all do better. So tours, workshops, webinars like this one, we coordinate. We've coordinated a culvert tour in the past with partners to kind of go around and look at how can we make culvert work better. And I think we've improved because of it. So I guess that's where I'll leave it. And I will pass it off to Matt Kempinger, who's going to talk about a really cool project, Gorman Creek.
Thanks, Jennifer.
Mhm.
Yeah, I'm excited to share a project that I got to work on in Wabasha County here, Gorman Creek. It's a couple of years old now. I think about 2023 is when we wrapped everything up, but it took a couple of years to kind of go through the whole process. So this will be a more specific project focus presentation, but incorporating really a lot of what was talked about in the previous presentation. So when I first started with Wabasha Soil and Water Conservation District about 6 years ago, coming from a background more focused on aquatic habitat, stream projects, fisheries, into a role that I kind of anticipated being more ag related, erosion control, farming practices kind of things. I was really excited when this situation was given to me, a problem to solve that there was potential for a really cool stream project to go in Wabasha County here. It's a really unique site. Just upstream of this project, you can kind of see in that picture there with the red polygon. That's a LiDAR view of the project site that was given to me. You can see just below that, which is upstream on the south, there is a pretty obviously pre-restored looking site, and that was a project that the DNR had done in about 2004. I think it took them a couple of years, 2003, 2004. So immediately upstream, going all the way to the headwaters spring, there's a really nice restoration, and then immediately downstream on the north side of this project site, there's a wetland bank. So protected and restored areas on both sides of it, both coming straight from springs, so it's protected all the way from the headwaters. And also, this whole watershed by Southeast Minnesota standards is pretty heavily wooded, a low percentage ag compared to the average. So overall, just an excellent potential to do some work. The pre-existing conditions were, as a lot of sites are in this area, a straightened ditch that has been incised over time, pretty limited habitat. You can see there were two channels that come together in this project. We call Gorman Creek itself, we call the main channel throughout the project, and the other channel is an unnamed tributary, but really the only habitat that existed in either one was the vegetation that was present in that tributary. A bit of the history. So when I got this site, it was kind of presented as we have some amount of a budget here to do a project, but it can't. So the DNR is the one that proposed this after they did their previous restoration. They purchased an easement on this site, knowing that it was a goal to eventually do some sort of restoration here to continue it downstream. So we knew the budget, we knew kind of the confining area that we had to work with, and other than that, it was a bit of a free for all of what we could do, a lot of flexibility, and that was an exciting thing. So I first dug into historic imagery to see what was really going on here. You can see even going back to our earliest air photo in 1938, that was prior to the ditching and straightening. There's a little bit of something going on in the main channel there, but you can still see the path of trees there where it was meandering, and a nice sinuous, what we would presume to be healthy E channel at that time by Roskin stream classifications. And then as you go through time, it was first ditched pretty heavily in the main channel, and then the tributary following. This goes along with, this is just kind of an example graph from a study done on the Whitewater River, which is another a little bit larger river system and watershed here in the southeast, where there was a study on legacy sediments, which looks at the pre and post settlement and ag and forestry introduction here, what impacts that had on these valleys. This being a similar landscape position, kind of low in the valley, flat floodplain area. Um, many of these areas, anyways, have a clear original pre-settlement soil horizon that you can find when you do borings, and that's this lowest line on the graph here with the wide floodplain that you can see, and then some new layers over time of sediment accumulation from erosion that's going on the hill slopes and upstream in the watershed, resulting in that stream initially having to raise with that and then incising back down to or below that original stream bottom. So that was a problem we faced here as well. We took the geomorphic natural channel design principles and attempted to apply those here, just like mentioned and kind of gone into detail on the last presentation too. But the basics are mimic nature as much as you can and do that by applying reference reach data, which is just the conditions and parameters of similar streams and similar landscapes that we know are functioning as close to natural as possible. So along with that, using all natural materials and focusing heavily on that bank fold dimension to kind of modify those reference reach parameters and connecting the floodplain. The reference reaches we used for this came from a similar study on the Whitewater watershed. This aerial imagery here is taken from one of the headwater sections of the South Branch of the Whitewater River, where you can see that sinuosity and that floodplain connectivity. Even from this air photo, you can tell all that's still present in that site. But really, the data that we used to come up with those parameters down in the bottom came from a variety of sources, and that included historic Gorman, so some measurements we took from those old air photos and survey that we did, and then even some sections of the Red River area in Minnesota. Here's a look at the plan view and what we were calling the phasing approach to this project. Because this site had such a flexible easement area to work with, we had the opportunity to do something really unique and just completely re-meander the whole stream. Originally, this section of stream was about 2,000 feet in length total when you combine the tributary and the main. And by the end of it, we were able to increase that channel length on this property to almost 5,000 feet. So more than doubling the total stream length here, as well as achieving other goals. So we we had a unique flat area to work with, which was handy for kind of being able to really balance out costs and optimize that. We had to implement that phased approach that I talked about because in order to get the channel to not look like a designed system, which is a goal of that natural channel design process, it meant crossing the channel in a few places to not only increase the meandering of the channel, but increase the meandering of the floodplain that was associated with that. So we did kind of two separate alignments here. We were able to create a floodplain alignment that had its own meander, and then within that meander the stream around it. And because of that, crossing the original channel, we elected to do this phased approach where when the contractor got started, we first constructed the off-channel portion, so where it wasn't crossing, so that those areas could be excavated in the driest conditions possible, and then have time before they were connected up to allow vegetation establishment, so those banks were protected before we had flow reintroduced to that. I mentioned a little bit about balancing the costs. A large portion of this project was clear at the beginning to be associated with just sediment removal. And in order to minimize that, we came up with this idea to create a significant grade break near the downstream end that resulted in us being able to raise the majority of the channel significantly, therefore decreasing the amount we had to excavate to build those new floodplains. So this is just kind of a an idea. You can see a rough profile there for what we did to achieve that, and we still stayed well within the parameters for those reference reach slopes. This is an actual profile shot showing the same sort of thing. Those purple diamond dots show the original channel profile. It's just kind of a straight line with a little bit more slope than what we had and almost no pool riffle ups and downs throughout the whole length of the project. And then the black circle profile there represents the finished product where you can see it is flatter overall on average until that downstream end where it really slopes down. But even through that other section above it, it's got pools, it's got riffles, and a lot of diversity. I mentioned the legacy sediments, and when we were digging the new channels out, it was very clear that that applied to this valley as well. You can see in that upper left, I found this super cool. That upper left photo had already been cut down about a foot from the surface there, so you can imagine that top soil horizon being about double the thickness, but then immediately below that, there's that really dark soil horizon, and we can pretty safely assume that that was the original topsoil pre-settlement, and it was really cool to see that that tied in with where we had the floodplain cut down to for a lot of the site. So it was truly restoring it, and we didn't know that until we dug, but restoring it to similar elevations to where it would have been originally. The contractor elected to do almost all of this construction in the middle of the winter and overnight to ensure that the ground was frozen because you can see even doing that they had struggles with wetness there, but we worked with them on that and we were able to make it work. That freezing ground was critical to installing this project. Here's a bit of a time lapse. You can see I didn't one of the things I wish I would have done better in this project was document pre-existing conditions so we could really show how we improve that. But here we got Google Earth that kind of does the job. You can see original and then that first phase of the project where we were just starting in the winter to do those cuts of the new channel, but not connecting any flow until we had a chance in that third photo there in May of 2023 to give it a whole growing season of vegetation establishment before reconnecting flow to those new channels and filling in the old channel with that March 2024 photo. We didn't only do re-meandering. We also took what was left of our limited budget to install as many habitat practices as we could. And as you probably saw in some of those earlier photos, there's no coarse sediments down in this valley. It was 100% clay and that layer of organic matter. So there was a spawning population of brook trout already here, but pretty much confined to the far upper pool near the spring that was actually across the road from where this project started. So we wanted to increase that, knowing that the population's already there, the water quality's good, and they just needed some gravel to spawn on. So we installed at several of the riffle locations here about 273 linear feet of uh, appropriately sized gravel for brook trout spawning. And immediately in that first year after we put it in, they were using it. There were reds, and we saw trout sitting on it at those locations. So that was really cool to see. This is a photo of that road crossing that I just mentioned, where immediately upstream of this is where the spring comes out of the ground less than 100 feet across the road here, and it's always been full of brook trout. They spawn up there, and that's really been where all the habitat on this whole reach was. So you can see about 8 to 10 inches, maybe 12 inches of drop in this photo based on that water level, where the culvert had been at a high elevation compared to the water surface. We connected that with the water surface here post project to give those brook trout even better access to the whole system. The main grade control practice that we used throughout this project was what we called hammerhead pools, which just involved keying in some riprap to the existing banks to hold it really solid in place, and then building a riffle at a very specific elevation based on our bankful measurements, and then a tight meander with towwood and a deep pool for some deep habitat. And then really the last kind of extra habitat practice we did was installing some cover rocks, which is just a layer of big 3 foot, 4 foot diameter or 4 foot width boulders that there were two layers, one to form a solid base, and then the top layer that overhung the bottom layer by about 6 inches to a foot to provide some shade and cover for fish to hide under. And then here's just a look at that zoomed in section on the downstream end where I talked about before. We created that steeper section at the bottom to allow us to raise the entire portion above it. That was pretty steep, about 1.7% slope, and without doing something to add some habitat in there, it would actually could potentially be a little bit challenging and slow fish passage to some degree. So we did this by installing some really large boulders and digging out small pools behind them, just to allow rest areas as they work their way up that steep section. And that turned out really well. Um, this also serves as really solid protection for the above portion, because really the biggest risk with raising the whole channel like we did would be if it found a way to cut back down, and then it just work its way all the way back upstream. So this was heavily anchored and really, really well established to prevent that from happening. Lastly, we worked close with the landowner. He's a grazer. He has kind of various farming practices, but this area of his farm, he always has a few cattle on, a few horses too, and he wanted to make sure that what we did, really his only focus was that it didn't impact how he used it. He agreed to do only temporary grazing on the areas right around the stream, but certain portions that were a bit further on the other side of the creek he needed access to, so we installed some cattle crossings for him, or I should say a single cattle crossing and an off-channel water source so the cattle didn't have to get right down in the stream. So you can see there's already some swans using that off-channel water in that photo on the right. It really serves as a good wetland habitat, if nothing else. And I don't know, I probably got enough time to quick show a drone overview of the finished product here, and I'll talk a little bit about it as I go. This is looking at that main channel, so Gorman Creek itself. You can see we did give the contractor a little bit of flexibility on just how big to build those hammerhead pools. They might look a little bit out of place. He got a little bit overboard on some of them, but they are all still functioning. We made sure of that. And there's very low sediment accumulation in this system, just because of those factors that I talked about earlier with the protected watershed. There's that downstream section with the rock arch rapids or boulder rest pools is really a better way to describe that. Going into that wetland bank downstream. This drone imagery was taken basically immediately after it was constructed, so you don't see any of that really good vegetation coming in yet because it's past that first growing season. But it is really looking nice now. There's that off-channel water area, and this is the tributary portion that goes up to that area with the spring where the brook trout had been using in the past for spawning. You can see some of those cover rocks there just above that big hammerhead pool. And really in that corner there with the trees, that's right where the spring comes out. It doesn't go any further than that. There's no upstream portion of the stream beyond that. And here's lastly just a couple photos to show how that vegetation has come in. And really that is the primary habitat in this e-channel system is the deep channel relative to its width and overhanging vegetation that provides all kinds of cover for them. So we're really happy to see how it's been going. Couldn't have done this without help from partner agencies and really good contractors. We worked close with the DNR, SWCD, and then the technical support with SWCD and Trout Unlimited as well. So I think at that point, it's time for questions.
Great. Thanks so much, Matt and Jennifer. It was really cool to hear about these really good projects. So I'm Chelsea Blanke. I manage the Ecological Restoration Training Cooperative at the University of Minnesota here. I'm going to be monitoring the Q&A. So I'm just going to jump into some of the questions from our audience here. The first question is going to be for both of you. And that is the availability of qualified contractors a limiting factor in completing projects? And are there generally enough contractors available interested to ensure competitive bidding?
I guess I could jump in first. So far in my experience, we haven't had issues with finding a good qualified contractor to do the construction. Usually we get several bidders. I think in the long run, at least in southern Minnesota, we've had kind of have one contractor who is usually the lowest bid, and he's very well qualified and very good. And he's got a really good crew. Eventually, it would be nice to have more contractors with more experience. I think there is a limited scope of experience among contractors, but I don't think it hasn't been a problem really for us yet. So,
And I would agree with that. We weren't too worried about having qualified contractors. I mean, we put in the work knowing that if we got some low bids, even if we had to go with those, we would be providing the technical assistance and oversight needed to ensure that this was done how it needed to be. But that was maybe a specific situation for our project. And regardless, we did end up getting many bids for this, and a qualified contractor won that bid, and things went smooth. So
That's great to hear. Kind of keeping with the sort of planning pieces of this, do you have permitting challenges associated with re-meandering or raising the stream bed? So that could be maybe for Matt or other sites.
in my experience, no. And this is really the only site that I have done that on, and it came from the DN from sourced from within the DNR in and people that were well involved with the permitting process and aware of those hurdles already. So we went into it knowing that that was going to be a factor. And I can imagine there's challenges with that at other sites. This was a unique site.
I think with doing anything where you're kind of moving the channel at all or creating more pattern, even if it's not cutting a new pattern, if you're, reconnecting an old channel or something like there's the EAW that's required. And so that can add some length and cost onto the project. And maybe in some circumstances might dissuade a project owner from kind of doing the right thing with the geomorphic design and the pattern because of the extra time and cost. But it makes it a little more challenging, but it's, kind of the reality that we work in. And I think it's always good to still, do the AW and do the pattern the right way, in order to, instead of avoiding the permit and just doing something that's within the existing channel, if that makes sense.
Yeah. So this next one is going to be about working with landowners and stakeholders, and this kind of came up during Jennifer's talk, but I think Matt, you might have some comments on it too. So you discussed implementation of landowner stakeholder wishes, like the trees planted or the boulders in the pool. If the landowner or nearby community has another species in mind for habitat conservation, is stream design or restoration priority always trout habitat for Trout Unlimited? Or can that also be a secondary goal if other partners are in agreement?
I would say for trout unlimited, I would say I think it's safe to say that the primary goal for us would probably always kind of lie in good cold water habitat for trout. But that's not to say that if there's secondary species of concern. I mean, one thing that we're trying to do, I guess, in both Northeast Minnesota and Southern Minnesota is try to do better with the riparian vegetation management, realizing that these are important, habitats for, migrating birds and insects and pollinators and all kinds of stuff. So it's kind of always in the back of our heads, like how can we uplift the environment or uplift the ecosystem in these riparian corridors for other species that might be here. And I know like there was just a really good talk at the Upper Midwest Symposium this year about, the potential for like herpetological considerations and stream design. So I think that's always something that should be a close second priority to the trout habitat for us and something we're always thinking about.
Matt, would you like to comment on?
I think that was an excellent way to put it. Even for outside of TU, it is generally more difficult to come up with the funding in situations where that's not the primary focus. But I think there are opportunities. It's just harder to find.
And one thing too, I guess I'll put in a sort of some praise for like our consultants that we work with. A lot of them have really good backgrounds in conservation biology and ecology and the natural history of these species. So a lot of them I see, coming up with really good ideas for ways that, you can take a habitat improvement, like your standard old habitat improvement project and really expand it to really address a lot of other species. And so I think again, that's something where outcomes are really improving over time.
Yeah, great. Yeah, great to think holistically while you're at it, right? So, and then kind of keeping on the landowner kind of questions here. How do you go about approaching landowners? And that'd be for both of you.
Just from my position in what I do for work, our approach is almost always landowners coming to us with concerns. And when we can fit in a larger scale habitat practice, we jump on those opportunities, but really they come to us, at least in my role in all of this.
For us, it depends a little bit on where we're doing the stream project. If it's within like a DNR easement or a DNR conservation easement, oftentimes, we're letting the DNR reach out and to landowners about the potential for doing a project, and then to make sure that they're informed about it. They don't necessarily get to decide whether it's going to happen if they've sold the easement, but we just want to make sure that they're notified and informed, and if they do have concerns that, we can know about them, which is why, from the design process, we incorporate the landowners into design walks and make sure that they kind of know what's happening and what to expect. Sometimes we'll have landowners come to us and, especially with the easement process, like I have personal experience with this. I sold an easement on trout stream, a DNR fishing or angling easement on the trout stream that runs through my property. And this is before I worked with TU, and I was like, okay, so like, when's the restoration going to happen? And so sometimes it's managing landowners' expectations with, when you sell an easement, you're kind of playing the long game with restoration to happen, because, there's this whole prioritization. I don't know if process is the right word, but there's always conversations with the agencies that manage the resource and other stakeholders. And yeah, so I guess the landowner stuff, we rely on DNR a lot to help us with landowner communication.
Got it. I have a couple more for you that are kind of getting at sort of some of the specific techniques. So someone is wondering, are cover rocks better for habitat than tow root wads?
I don't have a perfect example with data to support one way or the other on that. It was just all about diversity. We wanted to mix it up, not have all of one thing, and that was a great way for us to achieve that in this specific project.
I would say, if I'm understanding correctly, I think they offer different things for maybe different ages of trout, or like, like a cover rock is great to put in the channel, and it provides like a velocity refuge during, faster flows, and maybe some cover from avian predators for larger fish. Whereas I think of like the root wads and the bank as being better for maybe cover for smaller fish and, surfaces for macroinvertebrates and things like that. But I think both are great.
And then relatedly, do you do projects that focus on single or small reach habitat improvement structures?
Of course. Um,
We do occasionally, but it's just a matter of finding ways to fund those practices or projects that can be a little bit more challenging. So, yeah.
And then I guess related to that, this is probably going to be the last one we have time for. What funding sources have you used to successfully fund long-term post-project monitoring?
So for us, so again, so the monitoring is tough. So that's where we kind of partner and are opportunistic with, if, sometimes our projects are in sites that are long-term monitoring stations for DNR. So they're going back and they're electrofishing there year after year. And so that can give us some data and insight. For long-term work, I mean, we do include in our LaSARD proposals money for ongoing riparian vegetation maintenance and added enhancements and improvements, particularly for the old projects, like the projects that are now like 8, 10, 15 years old, where we can go back and do some added enhancements or kind of tweak, or, we find that like a small investment of maybe fixing something on a project that's 7 or 8 years old can increase the longevity over time. So that's kind of what we're trying to do.
Yeah, and that's still a learning process for us too. Like I think Jennifer kind of hinted at, we're figuring out that portion of it all and realizing how important it is. And still working out. We did incorporate that in this project and with the help of TU on that portion. But I think it's a case by case thing.
Yeah. Yeah, I was excited to hear that you were able to fund some of that ongoing maintenance afterwards. So I think with that, that's about all we have time for. If participants have additional questions, it'd be okay for them to reach out to you by email after.
Yep.
Great. All right. Thanks so much for sharing these great projects and ideas and yeah. Thanks everyone for attending.